Hey everyone, it's me, it's Morgan, right back at you with some more gases. Now, if you notice here, it says, now you try. So why don't you pause the video and go and try to do these problems, okay? I'll count to 5. All right, so it's probably about 25 minutes later. Actually, let's see how you did. The answers were here, but I want to show you how we got there. Density equals molecular weight times P over RT. This is something that in the classroom I would have given you a period to work on. Okay, so for the F, 5 times 19.00, 1 times, it's 30.97. Okay, so 125.97 will be the molar mass there for PF5. I do really miss having the group work days and walking around to different stations to see how y'all are doing. Okay, molecular weight, the pressure at STP is 1.00 atmospheres. R will be 0.0821 liter atmosphere downstairs, and mole Kelvin upstairs, 273 Kelvin downstairs. Moles is gone. Atmospheres, Kelvin, I've got grams over liters. That's good for density, and it's 5.62. Now, much more realistic would be using this to determine some empirical molecular formula. So, 92.24% carbon, 92.24 grams carbon, 7.76 grams hydrogen, 1 mole carbon, 12.01 grams carbon, 1 mole hydrogen, 1.01 grams hydrogen equals. So it's going to be 7.68 moles and 7.68 moles, which means I have a 1-to-1 ratio. I can divide by the smaller of those two numbers. And get that, okay? So it's CH for an empirical formula. All right, molecular weight equals dRT over P, which equals, now, density is mass over volume, okay? So the mass was 0.65 grams. All right, I'm in torr this time. So I'm going to use 62.4 liter torr per mole K. For the temperature, 27 degrees is a nice round 300 with a decimal Kelvin. Okay. The pressure, 750 torr. So torr is gone. Kelvin is going to cancel. Okay. And now, oh, you know what I didn't get in? I didn't get in volume. Density is mass over volume. Okay, so let's look at this. 632 milliliters, 0.632 liters. That's why I love units. They tell you when you have made a boo-boo. And that comes out to be about 26 grams per mole. Now, CH is about 13. Carbon's 12, hydrogen's 1. So 13, that's going to be twice. I'm looking at C2H2 for this compound. Okay? All right. Now, got another one here. Carbon, hydrogen, and oxygen. 37.5 grams carbon. 49.9 grams hydrogen, 12.6, no, I'm sorry, that was oxygen. oxygen, 12.6 grams hydrogen. Okay, boom, boom, boom. 1 mole carbon, 12.01 grams carbon. 1 mole oxygen is 16.00 grams oxygen. 1 mole hydrogen, 1.01 grams hydrogen equals. So I get about 3.12 moles, about 3.12 moles, that's a 1-to-1 ratio it looks like, and 12.5 moles. So when I divide that by 3.12 for every value, equals 1, and that equals 4 basically. Okay, so it looks like I'm looking at CH4O for my empirical formula. Now let's find a molecular weight based on molar mass data. MRT over PV is probably the better way to write this one out. The mass this time is 0.276 grams, 0.276 grams, times, let me find my pressure. Pressure is in torr again, so 62.4 liter torr per mole K. My temperature, okay, 95, so that's going to be 368 Kelvin. Pressure, okay, 740 torr. And the volume is 0.270 liters. Okay, so torr is gone, and the liters is gone, and Kelvin is gone. That leaves me grams over moles. Okay, which comes out to be about 32. And that's pretty close to what CH4O is going to be. 12 and 16. Yeah, that's right what it is, actually. So that's also the molecular formula. So let's look at about a possible structure here, maybe. Carbon. Put that in the middle. We'll throw 3 hydrogens on that carbon, and probably an OH group. So that is very likely going to be methyl alcohol, CH3OH. All right, that's page 11. Thanks for tuning in.